In this video, we're continuing section 7.2, which is looking at describing, and in our case, we're kind of thinking of this as summarizing data. And we're going to look at what's called the box and whiskers plot. In statistics, we call that just a box plot. But in elementary school, we like to refer to it as the box and whiskers plot because it kind of looks like it's a box that has whiskers. So the box and whiskers plot basically is a way, again, of looking at the data as kind of a snapshot, and it gives us some good information. The data in the plot, the data is divided into 4 parts. Now, unlike the graphs we did in the last section, in order to do the box and whiskers plot, we actually have to do a little bit of summarizing of the data to actually draw the plot itself. Okay, let me give you an example of a box and whiskers plot. Every plot hovers above a number line. So that's an essential part of it. This particular number line is going to go by 5s, starting at 0 up to 30. Okay, so I didn't need to go that far. Cool. All right, and the plot itself has a dot right here, which is at the number 1. And it has a bar that starts right about here or so, which is at the number 7. Another bar at the 15. A bar at right after the 20, which is, I think, supposed to be 21. That forms the box. This forms the first whisker. And then the largest value over here is sitting a little bit to the left of 30, and I believe that's 29. Okay, so I kind of labeled that so we know. Here's a box and whiskers plot, and it is dividing the data into 4 sections, but I'll talk about that in a second. Right now, this shows me what the data kind of looks like. That first number literally is the smallest piece of data, and the last number is the largest piece of data, and I will label that in just a second, okay? But you can kind of see how symmetrical the data is based on this box plot. So here is section 1, first section, second section, third section, fourth section. So this is the 4 sections dividing it into 4 parts. But it comes from 5 key pieces of information. This, which is the lowest value, and happens to be what I'm going to refer to as the minimum, okay, but I'm going to abbreviate it MIN. This is what they're going to call Q1. Q1 is what's referred to as the first quartile, because it's the first marker of the first fourth. The second one here is Q2, or the second quartile. It marks the second 25%, okay? But really, more importantly, it marks the halfway mark, which also happens to be the median. And that's going to trump calling it Q2, by the way. We won't call it Q2. We will call it the median. This is Q3, which hopefully you can guess is the third quartile. Kind of marks the 75% mark here. And then the last value, the highest, is what we'll call the max. And these 5 numbers make up what's called the 5-number summary. Now, I want to point out the book doesn't actually really define that, but I'm going to define it because I teach statistics and I think it's worth mentioning. So minimum, Q1, the median, Q3, and the maximum. That is the 5-number summary. It summarizes the data. It gives us a picture of kind of how balanced the data is or not balanced. It's possible that it isn't balanced. And it gives us a central tendency by giving us the median. It's a lot of information in one graph, and that makes it very useful. And it is used extensively in statistics. Okay, now to find Q1, the first quartile, you find the median for the lower half of the data. Now, there's supposed to be an of. Lower half of the data. So when you look at the data to find the median, right, you like literally split the data in half because you found the median. You'll take the lower half and you find the median of that. That's Q1. To find Q3, oops, you find the median of the upper half. All right. Let's go ahead and give it a shot. Oops, I'm sorry. Let's go ahead and give it a shot. All right. Let's form a box and whiskers plot for the following 20 test scores. And actually, just so you know, if you don't feel like writing this down, this is the try it in section 7.2. It's try it number here. Sorry, I'll write it down. It's try it 7.22, and that's on page 444, just in case you don't feel like writing it down. Okay, I am going to write it down though. So here we go. 55, 59, 64, 64, 68, 70, 73, 74, 76, 77, and then 81, oops, 81 again, 82, 84, 85, 85, 87, 92, 95, and 98. So they were nice enough to put it in order. And the fact that they stacked it was also nice because since we know there's 20 test scores, the top row is 10 of them and the bottom row is the next 10. So they kind of split it in half for us. So sweet. We're able to actually find the 5-number summary pretty easily from this. So let's start. I'm going to start with the minimum. That's going to be 55. Now, since they went ahead and split the data into two, this is the lower half, and this is the upper half that I was referring to. So I want to find the median of the lower half. That's going to be Q1. Okay, so looking in the middle, let's see, I'm going to go 5 in for each direction. So 1, 2, 3, 4. Wow, I did that wrong. Let's try that again. 2, 3, 4, 5. 1, 2, 3, 4. Oops, I wrote it wrong. Hold on. Let me go back and make sure I wrote it correctly. I wrote that. Find what I incorrectly wrote. Let's see. 55, 59, 64, 64, 68, 70, 73, 74, 76, 79. Okay, now I'm going to actually have to turn to the page because I definitely wrote it down wrong then on my notes here. 444. Here we go. 55, 59, 64, 64, 68, 70, 73. Oh, that's supposed to be 75, not 74. 76, 79. Wow, did I seriously miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, there's 10. Oh, I know what I'm doing wrong. Wow. Okay, I apologize, guys. It's all right. It's good that I checked it because I had one value wrong. And those of you who might have looked in the book would have seen that and would have been like, oh, she made a mistake. It happens. Okay, here we go. We actually need to count 4 in. 1, 2, 3, 4. 1, 2, 3, 4. Oh, there they are. Those are the middle two. If I tried to count 5, there wouldn't be anything to count into. Okay, so we're going to take the average of those two. Here, I'll just do that above. 68 plus 70 divided by 2. That's actually going to come out to 69. Cool. Okay, median. So the median is going to actually be the middle of the two pieces of data, or the halves. And since it's even, again, it's going to be the middle two data. If I were to put these two side by side, right, it'd go 79, 81. So it's going to be between 79 and 81. So 79 plus 81 divided by 2, that's going to come out to 80. So that's the median. Okay, so for Q3, we're going to go to the bottom two. I lined it up nicely, so boom, there it is. 85. So exciting. And then the maximum is going to be 98. All right, there we go. There's the 5-number summary. Whew, that was a lot of work. It's fine. It's good for me. And let me go ahead and draw now the box and whiskers plot. So I see that the lowest value is 55, highest value is 98. I feel like going by 5s is reasonable. And that's what I'm going to do. I'm going to draw my number line and go by 5s. So I'll start with 55. 60, 65, 70, 75, 80, 85, 9. Oops, I was a little bit close. Sorry. Trying to be as even as I can, but it's not perfect. 95, and then here I'll go out to 100. And there we go. All right. Not perfect, but it's fine. So 55 is going to go right here. 98 is kind of more towards the center here. 69 is going to be just a little bit less than that. 70, 80 is going to line up nicely above there. And then 85 will line up nicely there. Okay, so here we go. Now, what I notice about this box and whiskers plot, if I was trying to kind of observe anything, is the median isn't centered, right? We kind of see that the median is a little bit off center, which kind of implies that maybe the lower score happened to be further away from the median than the higher score. So maybe they scored significantly lower than most others. That's just kind of what that means. It's still pretty darn symmetrical. And what I'm looking at when I'm looking at symmetry, I'm kind of looking at how spaced out the whiskers are for each other. Like, are they vastly different? Is one super long compared to the other? And the answer is no, not really. Okay, now here is also why the 5-number summary is really nice. And it allows us to find an outlier. So to find an outlier, we need a concept called the interquartile range. It sounds so fancy, but it isn't. We call that IQR, by the way. IQR is just the difference between Q3 and Q1. So it's literally just measuring on the box and whiskers plot. It's measuring the length of the box, how long the box is. Okay, now to find the outlier, we also need something called the fences. The fences, and I want to mention here for a second, the book does not call this the fences, okay? It just kind of describes the process. Doesn't use the word fences. I'm using that word because, again, I have a statistics background, so I know it's called fences, okay? That's why I'm calling it that. There are 2 fences. One's called the lower fence and one's called the upper fence. I'll actually write out lower fence in a second, so you know that that's what LF represents. LF equals Q1 minus 1.5, the number 1.5, times IQR. And the upper fence represents, Q3 plus 1.5 times IQR. I should also mention the book is kind of like fuzzy about saying Q1 and Q3. They call it lower quartile, upper quartile, if I recall as well. I think they do label it at one point Q1. Yeah, they do. They do use that notation, but they don't call it first quartile, third quartile. For some reason, they call it upper and lower quartile. And that's fine. I think they're just trying not to get super precise because statistics has a lot of precision to it. Okay, now here's how we find the outlier. To find the outlier, if the data, or if the data value, I should say, if the data value, sorry, my computer's kind of being a little bit sluggish here. If the data value is less than the lower fence, so I'm going to write out the phrase, the lower fence, which we used LF, or bigger than the upper fence, which we used UF, then it is an outlier. So any data value that goes outside of the fences, right? Smaller than the lower fence, bigger than the upper fence, that becomes an outlier. Well, let's test this. Okay, let's test this. We have a couple examples kind of ready to go for us here. So let's look at, for the test scores we just did, for the 20 test scores, let's test for outliers, okay? So I'm going to find the lower fence. So Q1 was 69 minus, oh, here, let me go ahead and find IQR real quick. So IQR is 85 minus 69, which is that 16? Or, wow, sorry, that's actually, no, it is 16. Okay, good. That's a sad looking 8. Let me fix that. 85 minus 69 is 16. Okay, cool. So we're going to do 69, which is Q1, minus 1.5 times IQR, which is 16. All right, I'm going to plug that in my calculator. And I get 45. So any score lower than 45 is considered an outlier. That's what that means. Upper fence. For the upper fence, we'll take Q3, which was 85. And this time we're going to do 1 plus 1.5 times 16. And for that, I ended up with 109. So any test score higher than 109 would be considered an outlier. Now, if this is tests out of 100, this is impossible, right? Which basically means it's impossible to have an upper outlier for this test, okay? Unless there's extra credit or something. But it is possible to have a test score too low. But for us, our lowest test score, here, I'm going to scroll back up here, happened to be 55. So we don't have any outliers. So I'm going to write that down. No outlier or outliers. That's what we conclude from there. So there happen to be no test scores outside of those values. I want to go back then to the commute times. And I'm going to write it in order really quick. We had 6, 10, 11, 11, 17, 18, 20, 29, and then 48. Okay, so for this one, the median, is 17. The minimum is 6. Okay, I'll write the 17 down just a second because I want to go ahead and do the 5-number summary in order. So Q1 is halfway between. Okay, so whenever you find the median, you kind of exclude that. So I look at the lower half of the data And then here is the upper half of the data. So I kind of ignore 17 since it happens to be in the middle. So to find the median for here, I'm going to look at these two values here in the middle. Okay. So that's 10 plus 11 divided by 2, which is 10.5. That's Q1. Okay, the median I already said is 17. Q3, I'm going to find the middle of the upper half here, which would be between 20 and 29. So adding those two together, dividing by 2, that gives me 24.5. Here, I'm going to zoom out just a smidge so I can fit this all in. And then max is 48. Okay, there we go. There's all my 5-number summary. I didn't need all of it. I really only needed Q1 and Q3, by the way. Okay, but I figured it was nice to find the 5-number summary since we've been working with that. Okay, so to find an outlier or to check for an outlier, let's use the lower fence. But before I do that here, sorry, let me find the IQR. So the interquartile range is going to be, 24.5 minus 10.5, which is 14. Okay. So lower fence is Q1, 10.5 minus 1.5 times IQR. All right. Grab a calculator. Do some calculating. I come up with negative 10.5. Check that one more time. Yep. Which basically means it's impossible to have a lower outlier. It's just impossible. Okay, for these commute times, it's just not going to happen. For the upper fence, we will do 24.5, that's Q3, plus 1.5 times 14. That one I get 45.5. Ah, so we actually have a data value bigger than 45.5 in our original list here, right? 48. So there we go. We do have an outlier on this one. 48 is an outlier. It happens to represent somebody who's coming farther than most. To the point that it's skewing the data a little bit is what that means. And if we were to graph the data, we would see that, how it's kind of skewing it. So I'm going to go ahead and do that. I'm going to go ahead and do a box plot of this, or a box and whiskers plot of the data here. Again, I'm going to just zoom out just a little so I can squeeze it all into this page. Okay, so here's my number line. Let's see, lowest value is 6, highest value is 48. I feel like it's totally reasonable to go by tens. 0, 10, 20, 30, 40, and 50. And then here, I'll just kind of put a middle mark just to help me for the 5s. Okay, just to give me kind of a little bit to reference. All right, so 6 should be a little bit above here. 10.5 would be very close to the 10. 17 would be very, or kind of in the middle right there or so. 24.5 should be really close to the middle here. Here's my box whisker. And then the largest value of 48 is like way over here. And there you go. Now we can kind of see that that value is like weird compared to the rest of the data. It's kind of skewing it a little bit. And therefore, that's why it makes sense that it is an outlier. An outlier kind of makes the data look skewed like this. And a box and whiskers plot helps us see that.